Hello class, it's Dr. Mike here with a few bits of Linux for you. So this week's topic, we're specifically going to talk about design scheme. So you ask yourself, what is a scheme? and great word, right? So before we move into that, we're going to talk about partitions also. These both go hand in hand together, but in general, what a scheme is, it is designing your system to meet its needs, so laying it out. And first off, let's talk about the basics. First off, your OS requirements. Whether you can do CentOS, Red Hat, Enterprise, Ubuntu, Pop! OS, whatever. And if it's a workstation, a laptop, to enterprise level server, it's going to depend upon what you need. So first off, there's the OS requirements. The OS is going to want, of course, a certain amount of CPU, a certain amount of RAM, and hard disk space. For most desktop and laptop, you can easily find that out, and most time any modern desktop laptop will run Linux. We're really going to focus this more on the enterprise side of the house here, the server side, or at least the high-end workstation side. This is where you need to design a scheme. What does that mean? So first off, we know we need to have CPU requirements, we have memory requirements for the system. However, what is the purpose of the system? Is it a web server? Is it a file server? Is it a development box? There's things we need to look at, like the number of users. If it's going to be a development box, how many users are we going to have? How much space is each user going to need? How are we going to do the logins? Is it a web server? If so, how big is our web content? A database server, how big is our database system need to be? And because we might use this in designing things like, first off, from our previous topic, services. If I'm running a web server, do I need a GUI at all? So that might dictate run level 3. On top of that, am I going to run cups? Am I going to run a print server, cups print server? Am I going to run a Samba server on there? And probably not. So I want to limit what I'm running for both performance reasons, integrity, and also security. Less stuff to run, less stuff to configure, less stuff to patch, less vulnerabilities I have exposed by running things I don't need. So this treads into what they call system hardening, which is definitely a deeper security topic. But it starts here, though. It starts at your designs. It starts with design. What you'll see with enterprise level servers is they will design out these aspects: CPU, memory, hard disk, number of disks we have available, disk usage, disk capacity. Then we have the usage of that. How many users are we going to run? What type of users do we need to have logged in besides root, of course? Is it a web server? What kind of services are these? Is it a web server? Does it need a GUI? Is it running on level 3 with only certain services on? Certain firewall rules, certain password rules. This usually is laid out into a design document, and then usually create a baseline of this, and you test it. And when you deploy a new server, use this baseline. This is called provisioning. You see this in the cloud, you see this in both physical too. So this is what the scheme comes about. Now the big part of this week's topic and the scheme itself is partitions. So because a large part of this is after the CPU memory is all taken care of, the OS is running, what do I need to have laid out? Because the way hard disks are laid out here, they have sectors, tracks, and cylinders, partitions. And really with partitioning, we're going to go move past this. These are more disk level things. Of course, here I have hardware, the read-write heads, the compilers. You can see here, and we're actually going to use this graphic here to talk about how this works. So first off, how do disks look in Linux? And what we have is everything shows up under our dev directory as for our devices. Now, older hard disks using the IDE bus starts with an H, D, and then there's a letter after that. So let's say this is an IDE drive. IDE is an older wide cable. And the reason I bring it up is you might be installing Linux to sort of refresh, revitalize an old piece of hardware. But even now, 2020, this has been recorded, even older stuff, a few years old, is probably going to be running what's called SATA attached, or SATA disks. We refer to as SDs. And there's a character for that. So dev SD something. Now, if it's the first physical disks, let's take this right here. This is the physical disks right here. This is the hard drive we installed. It could be SPIN, it could be SSD. It's still the same. We'll use SPIN for now because of the graphic. So our first hard drive here is SDA. Let's say I go out and I buy a second hard drive, maybe for my database. Maybe I plan to put my database on this thing. It's internal hard drive. That's going to become SDB. So that's how that works. And it's the same on the side here with our IDEs, but we're going to stick with the SATA drive here side. So on each drive, then we split into partitions. So really break it into smaller chunks. These partitions are going to be numbered. 1, 2, 3, 4 you might see used here as an extended partition. We'll talk about that in a second. And 5, let's say 6. So very common you'll see is mount points or directories mounted to these partitions. Let's say SDA3. So here's SDA and number 3. That's mounted to my root directory. Maybe SDA2 is mounted to, let's say here, mounted to my boot directory /boot. Now there's something we're going to see here. It's called logical volume management, LVMs. We're going to look at this in a different video, but it is mostly the standard now. It's taking disks and sort of creating a pool of storage that you can actually pull from and even grow. But for now, we'll look at standard partitioning. Boot. We'll see this in the live system. So let's go ahead and keep that. So again, here we see if I do ls-l on dev, and I look for sd splat, here we can see, and this is the CentOS server, I have SDA, SDB, SDC. I have 3 hard drives. SDA has 2 partitions, 1 and 2. SDB has 1 partition, SDB1. And if we look at how disks are laid out here, again, you'll see LVM here isn't active with everything. Basically, everything is mapped to a logical volume. Again, we're going to look at this separately. But for now, you can see dev SDA1 is mounted to /boot, my boot directory. So in case, it's important to understand how this is laid out, because when you divide these up, you're going to figure out what divides into where. And what commonly you'll see is root and boot usually separate, maybe /temp. And we'll talk about these in a second. TMP, maybe on its own, and so on. But first off, though, that's what it lays out. We have the device, the drive letter, and the partition number. So again, partitions are stored in dev. We talked about that already. You'll see in the slider SD and HD. These are IDEs. So this is reiterating what I showed you. Now, after you partitioning is out, partitioning is the first step. Second step, we need to format this. After it's partitioned, we set aside that part of the disk from block X to block Y. Wherever the 5 gigabytes for, let's say, for home directory, that's really small, but let's say 50 gigabytes for home. We need to format it, and this is where this comes in. So If you look back at Windows, we have NTFS, FAT32. Those are common formats. With Linux, ext4 is pretty common, XFS, RiserFS, VFAT, and you're going to say, well, which one do I use? And this is where you go back to your scheme. What is my system going to be doing? Do I need to support working with Microsoft OS somehow? Maybe it's a dual boot system, so do I use VFAT? I need to use RHEL 7, Red Hat Enterprise Linux 7. Most common will probably be RiserFS, XFS. Most OSs will have a standard. ext4 is one of the standards. Also, as ext4 support very large disk volumes and file sizes, that could be a big deal. Am I dealing with a video production system where I have large files, right? Video files are huge. So also, we have integrity. ext2, the older ones, do not have something called journaling. So journaling can make it slower, but it adds integrity. Also does not support large file systems. Large file sizes also. So you can see you want to use the right file system for the need. And you can have separate file systems for separate partitions. I can have a partition SD, let's say SD A5 is VFAT, where everything else is ext4. And this boils back to our thing, what is the system made for? What is it doing? So again, this goes into that. What kind of activity am I going to be doing? This is talking about dual booting. Skip over that. So common things to partition now. First off, we'll see one of the big ones is our /home directory. /home, put the slash in for you. Real common to put /home, /temp, and also root on some partitions. /home, of course, is where our users have their own directories. So if I'm dealing with a multi-user system, maybe a development box with a lot of code being stored and a lot of users writing code and storing code, /home will probably make it a good size. I can also put something called disk photos in place. That's separate. We're going to talk about that separately later in this course. Also, I can back it up. I can back up the home partition and always reinstall the OS and then restore home, and everyone will have their files. So partitioning has a lot of things to help you figure out how to back up your system too. So again, how much space does each user need? Not just each user, each system. Let's say we're on a web server, which actually puts everything under var www by default HTML, and there's also a var FTP for doing file transfer. So looking at the configuration of not just the OS, but what is the application going to run? What's the daemon going to run with? And if you look at the documentation for Apache, you'll see var www is pretty common to have that for all your web content. So how big is our website going to be? How much is it going to grow? I don't want to set aside 5 gigs and find out I'm running out of disk space. Try to plan ahead for capacity and growth. Same with users. Am I going to run 10 users now, 20 in 6 months? How much disk space are they going to need? What type of content are they creating? Security, of course, very common. Again, /home and var log. Usually common to have var log on its own partition. This way logs can be protected. That way if var fills up, var log itself will still be running. And again, you can actually partition, you can attach partitions to not just var, but var log can go to a partition. Again, I mentioned home before, real common to put home on its own directory. So file system types, and then also partitioning. Very common to put root on its own. Again, LVM is going to throw in a whole different ball game. So let's go ahead and keep that on the back burner. But no, it's going to change how things look. But normally in common, var will get root will get its own file system. I say root, I don't mean /root. /root is the root user's home directory. That's usually going to be underneath, of course, with this partition, but that's separate from the actual root partition. So This is our OS. We want to keep it separate. Boot also usually separate. Even with systems with LVM, like our labs you'll see here, I just showed you, you saw boot actually had its own partition that was mapped to /boot. Everything else is under LVM. Newer versions of LVM cover everything, including boot. So yeah, I might even see that. /home, want to have that separate. /temp, very common to put temp on its own partition. A lot of times temp's used for system and users to write to. If, let's say, example, I'm writing a database and it's dumping stuff out, it dumps out, it goes crazy, it flips out, it dumps out a bunch of core dumps, and they all go to temp. If temp fills up, I can at least address my system. I can stop the database, I can dump stuff out at temp, free that space up. But if everything was underneath the root and it kept dumping, I fill up root 100%, then game's over. So, and you have a really bad situation on your hands. So, swap, opt. Real common opt is used for a lot of things: Google Chrome, Earth, LibreOffice, Oracle, stuff in opt. If you're going to run a database, again, check what the installation, and not just the OS, but what does the app, what does it need? If I'm installing Oracle and it goes on opt Oracle and it needs 20 gigs and I don't give enough space, I'm going to, off the bat, have issues. So I need to go back and redo the disk space. Swap. Saw swap earlier in install, one of the main things you do need. This rule here, 2 times physical memory, that's a guideline. If I'm running an old 1 gig old system, I don't want, I definitely want to give up some of my disk space for swap. The swaps will be used to move that stuff out of memory. If I'm running a 64 gigabyte enterprise level system, I don't want to take 128 gigs of enterprise level storage, which is very expensive, and just dedicate it for swap. If I'm swapping that much on a 64 gig system, then something's wrong. So figure out what. There's a little bit of art there, a little bit of voodoo figuring out what goes where. /USR. Again, most of the time when you install the system, this is OS files, including commands and software. But there is also a place for user local. For locally installed software. When users install something, or you install something for the users, it might go in here, the binaries. Again, var, big one. Var log might have its own partition, as well as var HTTP or var www or var FTP, or my mail if I'm running a mail server. And I want to make sure those partitions are large enough to handle the capacity of what it needs. So again, you can see this here, simple command. If I just ls, again, dev sdb, you can see those are there. I'll look at Fedora, dev sd splat. You can see Fedora here we have 3 hard disks, SDA, SDB, SDC, and SDA has 2 partitions. df-h, or just df. You can see, again, we have logical volume in play, so it's going to not show us anything else. But we do have SDA1 mounted /boot. So later we're going to talk about, in an upcoming lecture, how to create these partitions and how to format them. All right, thank you.